to hold. Today's conference will begin momentarily. Please continue to hold. Thank you. Please continue to hold. Today's conference will begin momentarily. Please continue to hold. Thank you. Welcome to Thank At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star 1 on your phone to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I will now turn the call over to Joshua Finch. Thank you. You may.
Good afternoon. I'm Josh Finch of NASA's Office of Communications. I'd like to thank you for joining us for this call this afternoon for an update on NASA's Boeing Orbital Flight Test-2. Today I'm joined by Kathy Leaders, NASA's Associate Administrator for Human Exploration and Operations, Steve Stitch, Manager of NASA's Commercial Crew Program, Joel Montalbano, Manager of NASA's International Space Station Program, and John Vollmer, Vice President and Program Manager of Boeing's Commercial Crew Program. We'll start with updates from our presenters and then take questions from media on the call. And with that, I'll turn it over to Kathy Leaders.
So thank you for being on this call. I really appreciate your interest in this. This is obviously it's a disappointing day, but I want to emphasize that this is another example of why these demo missions are so very important to us. We use these demo missions to make sure we have the system rung out before we put our crews on these vehicles. You know, we conduct multiple rounds of testing and reviews before we bring a vehicle out to the pad, but over our spaceflight experience, in fact, in shuttle, we had 9 times where we had failures on the pad and we had to roll back. We have experienced failures on the pad, and when this happens, we have to have the maturity to stop, investigate, and fix before flying again. And that is what we are doing. We fly when we are ready. We are committed to continue to work with Boeing on bringing on their crew transportation system. And I know this is very, very hard on our NASA Boeing team, but I am going to tell you I'm very proud of them for how diligently and carefully they've been working through this problem over the last week and a half. And through their mental resilience, I know that this is a team that has the attributes that are needed for us to be mentally prepared to fly crews. So we're going to go fix this problem, and we're going to move forward. And this team's going to, you know, go figure this out, and we will go fly when we are ready. Thank you. And I think, Steve, you're next.
Thank you, Kathy. I would say I probably represent the sentiment of our entire NASA team, saying it's a bit of a disappointing day. You know, we're all looking forward to flying the OFT-2 test flight and testing out the systems on the vehicle. So it is just a disappointment to us that we're not going to go have this opportunity in the August timeframe. I'm extremely proud of the commercial crew team, the NASA side and the engineering, the Boeing team, United Launch Alliance for the troubleshooting that we've done and the long hours and the very creative testing that we've done to try to get us ready to go fly. You know, they've been very professional, been very resilient, dealing with, you know, tough weather and various setbacks, and a methodical approach to try to go test this vehicle out and get it ready to go fly. As Kathy said, it's always challenging to bring on a new system like Starliner, and people ought to remember that it's always been a challenge in space flight when you get to the launch pad. I was remembering this morning STS-114 where we had some engine cutoff sensor issues in the liquid hydrogen tank that ended up delaying us, and we had to roll back and swap out the external tank. As Kathy said, you know, on the morning of August the 3rd, we were getting ready in the countdown, and I know John Vollmer will talk more about this, but we noticed some of the valves in the propulsion system in the service module were not operating properly. These valves are important. They isolate the thrusters from the propellant tanks, and they needed to be open for flight in order to have the appropriate thrusters for aborts and on-orbit maneuvering for the vehicle. We stood down on that day, and we went into troubleshooting mode with the NASA and Boeing team working side by side. We worked methodically as best we could in the vertical integration facility to troubleshoot that problem and try to get the valves open and get to a flight rationale. John's going to talk more about it, but we could not get all the valves open. So we've decided to stand down, to roll the vehicle back into the C3PF and do more troubleshooting. We will work side by side with Boeing as we have all along in commercial crew, and we'll go find the cause of the valve issues. We'll fix them, and we'll go fly when we're ready. And with that, I'll turn it over to Joel Montalbano, the Space Station Program Manager.
Hey, thank you, Steve. You know, the Space Station Program is committed to working with Boeing and the Commercial Crew Program. Steve, myself, and John talk on a regular basis, and when the team is ready, we'll be ready for them on board the International Space Station. Since we last talked to this group on board Space Station and preparations, we've had a successful Northrop Grumman launch Tuesday evening, as many of you saw. That resulted in just an outstanding rendezvous, capture, and berthing that we had Thursday morning. And we're excited to have another Cygnus on board the International Space Station. We continue with 7 crew members on board, maximizing the use of the great facility we have on research and utilization, technology development for exploration, and low Earth orbit commercialization activities. With that, I'll hand it over to John. Thank you.
Good afternoon. So I'll start with some comments, and then I've got some background that I'd like to go through. So First of all, I'd like to start with a thank you to our NASA teammates for their technical support. It's been extremely valuable as we've been going through this evaluation and testing of the vehicle. And their partnership as always and commitment to get through this is extremely valuable. I'd also like to thank United Launch Alliance. We've been working very closely with them. Of course, our vehicle is in their facility, and so they have been very accommodating to have us work in their facility and do the troubleshooting that we need to do. I'd also like to thank Aerojet Rocketdyne, our propulsion system supplier. As we build the fault tree and work through that fault tree, NASA and Aerojet have been instrumental in helping us work through the trees and check off those items that are not issues. And finally, I'd really like to thank my team. Every one of them have been all in on finding a solution to this challenge. We've exhausted every possible option while still in the launch complex, and we've exhausted more options as we went into the vertical integration facility. And it's taught us a lot about innovation, what we can do when a challenge arises and what it takes to be safe working in a different environment. So, while we're obviously disappointed that we were unable to get these issues resolved in time to make this launch window. The launch window, while important to us, was not the driver. The driver was safety. We were working in a different environment than a factory, so we had to be slow, methodical, and deliberate, and so the team was. We took every precaution to make sure that safety was paramount. This Florida weather can be demanding at times, and so we made sure that we stood down as we went into lightning and lightning alerts and had the various weather that challenged us as well as the challenges we were trying to work through with the vehicle. So we are determined to get this spacecraft back and ready to fly at the next available opportunity. We are committed to support NASA and their mission with the best spacecraft possible. Other thing I would add is that, as I've said before, we will fly this test when we're ready to fly it, and it's safe to do so. And that's part of our core values at the Boeing company, and it's a commitment we've made to our customer and our company. We want to have the safest orbital crew capsule for NASA and every future Starliner customer. So we're continuing to act upon that commitment. But unfortunately, the time has come where we have to bring Starliner back to the factory. Once again, we've done everything possible. We can troubleshoot the issue in the facility that we've been at, and we got to get it back in the factory to continue with further troubleshooting. So although we will not be launching in August, it's not for a lack of trying. Like I said, the team went through a lot of collaboration and on-the-spot problem solving and troubleshooting. The team has been very resilient, and what they've demonstrated during this process is really remarkable. And this will ultimately give us a much safer vehicle in the long run. But I want to take a few minutes and talk about a little bit more about the details of the issue that we've been experiencing, because I know that'll address some of your questions. The vehicle, there's been the 13 valves everybody's heard about. We were able to recover all but 4 of the valves, and then we've done everything we can on those, and we finally looked at the timeline and looked at where we were and said, hey, we've got to go back to the factory. But big picture, there are numerous valves in the system. There are 24 oxidation valves, there are 24 fuel valves, and then there are 16 helium valves that pressurize both sides of the system. So there's quite a few valves just in this portion of the system, propulsion system, and so the fact that we had an issue with 13 of them was significant. I do want to emphasize that these valves, we use these during pad abort, We used these during the OFT-1 mission and without any incident, and so we really had no reason to suspect any issues with the valves themselves. Part of the test procedure at the pad is to go through a checkout of these valves, so it was not a random failure that we found. We intentionally go and cycle these valves, and we had actually cycled them, excuse me, before leaving the factory. So we had a good read on the valves when we left the factory. Of course, we had gone through our initial rollout for launch attempt, which was we had to stand down. We came back for this launch attempt, and we were going through our nominal checkout for launch preparations when we found this. The prior night, we had been through a storm, and so there were some erroneous measurements that we saw on the vehicle, so we were working through those measurements, and it turns out that some of those were related to the valve position indicators on these valves. And so it turns out as we worked ourselves through the fault tree, those were an independent issue. They were not part of this main issue that we're working through now, but it was something that we had to work through as well. So let's see. What we're working through right now is the most probable causes that we're looking at is that we're seeing some permeation of the oxidizer, which is NTO, through some of the seals in the valve itself. When that NTO interacts with moisture, and so there was some moisture on the quote dry side of the valve, and that interaction we believed created some nitric acid, and that nitric acid resulted in some corrosion, which resulted in the stiction of those valves. So that is primarily what we're looking at right now as the most likely cause for the issue. Now, we got a lot of things on the fault tree, and there's a lot of pieces of that fault tree that interact with each other. So we have to systematically go through and disposition all those items. But right now, that is our leading candidate for what has caused the issues with the valves. Now, having said that, we did get to a position where once we break the bond of that nitric acid, and we continue to cycle the valves did cycle reliably. So all the valves that we recovered, if we continued to cycle those valves, they worked fine with nominal commands. So we were getting to a point that we were feeling comfortable that with continued cycling of those valves, if we were able to free them all, we would have been in a good operational condition. So that's what we were shooting for, but obviously with not getting all the valves, we made the decision that we were just out of runway and we had to come back to the factory to complete anything else that we need to do going forward. So we will be looking at driving this to root cause before our next flight and ensuring that we have the safest vehicle as possible. So with that, I'll turn it back over to Josh.
Thank you, John. And we'll now turn to taking media questions. A reminder, you can press *1 to enter the queue. And our first question will come from Marcia Dunn with the Associated Press. Marcia?
For both NASA and Boeing, for a timeline, I know it's impossible to anticipate how long all the repairs will take, but at this point, given all the traffic at the space station, other events, what is the earliest you can envision this mission flying? Where do you think you can shoehorn it in, and what will that do to the subsequent crew launch? How far down the road now is that? Thank you.
I'll take the first part of it, Marcia, and then we can let John comment. You know, I think it's pretty early to speculate on where the flight might end up. You know, we really need to get the vehicle back into the factory and get our hands on some valves and then figure out what the problem is and how to correct it. I would say we'll work hand in hand with John and his team and Joel Montalbano on the space station program when we get to a point where we understand the cause and the fixes, and we will work hard to find that slot and get the vehicle flown as soon as we can. And it's important to NASA to get a second crew transportation capability online, and it's important to Boeing, I know, as well. And I'll turn it over to John.
Yeah, I'll just add that, obviously we've got to work through down to root cause, understand what it's going to take to make the repairs on the vehicle. And then we go through the normal things that we have to work with. We've got to find, time on the range. We've got to find time with our launch provider, ULA. And then, of course, with all the traffic at the station, we've got to work with Joel and his team to, find a slot that will accommodate us. So I don't have a pat answer for you, but I will tell you that we will get this vehicle ready as soon as possible and turn it around so that we can support NASA's mission as quickly as possible.
Do you hold out hope that this might happen this year, or is that unlikely?
Probably too early to say whether it's this year or not. I hope, we would certainly hope for as early as possible, and if we could fly this year, it'd be fantastic. But I at this point, I think that's would be too much to speculate.
Thank you.
And our next question will come from Bill Harwood at CBS News.
Hold on.
Yeah, thank you very much. Two quick ones from me. For Mr. Stitch, I know you don't like to give dates in situations like this, but for the record, you can't fly before Lucy, I'm assuming, so we're at least into November, right? I mean, there's no way you can launch before the end of October. Is that correct? And for John, I know you guys prepare for, rain at 41, where your vehicle is obviously exposed once it's out of the pad. Any idea how water could have worked its way in? And if you have to replace the 4 valves that still aren't working, how long would something like that take? Because it sounds kind of invasive. Thanks.
Yeah, Bill, I'll start with the answer. I should have made it very clear. We are definitely on the other side of Lucy right now. The reason we exhausted the troubleshooting in the vertical integration facility, there's really no reason to stay there, and we do need to get the vehicle back to the C-3PF and then let the Lucy mission proceed, the launch date for Lucy, a very important mission to explore the Trojan asteroids near Jupiter. That launch date, the opening of that period is the 16th of October. So we're definitely, this mission's definitely after Lucy. So.
Hey, Bill, on the second piece of your question there, relative to rolling out with the weather out here. So, yeah, the weather's not kind in Florida. The afternoons are brutal, and that's where our launch window wound up, and so we knew that ahead of time. We did not expect as severe a thunderstorm as we got, so we did roll out. There was the evening before, it was a fairly severe thunderstorm. We did have a close lightning strike, and for that concerned us for a while. Anytime we get something that close to the vehicle, and we do have protocol, and so we went to our protocol, and we did do some vehicle testing and ran through all of our systems to understand and make sure that everything was good. So after that, we did. From everything we checked out, we did see that we didn't have any damage to any of our systems from the lightning, as far as we can tell. Your other piece of this, which was the rain piece of it, we have covers over the thrusters that protect the thrusters from foreign material as we sit on the pad and as we wait. The storm was severe enough to disrupt some of those thruster covers, which did allow some of the water entry, but the vehicle is designed to be out in the elements and the hard environment of space, but there was some water intrusion there. We have gone back and remedied that as a separate item we've worked while we were at the vertical integration facility. So that piece of it we understand, and as we've resolved that.
Our next question is from Chris Davenport at the Washington Post.
Oh, hey guys, thanks so much for taking the question. John, you may have addressed this just in your last answer, but I wonder if you're now going to have to do a redesign of the valves, knowing that the water can permeate and move those covers. And then I guess for Steve Stitch or Joe Montalbano, wouldn't the flight have to come after SpaceX's cargo flight, given that the cargo Dragon's going to be on that port, occupying that port on the space station for some time, or is it possible to maybe move that around? Thanks so much.
Okay, hey Chris, this is John. Let me answer your first question. So let me make clear, the water intrusion through the thruster was not the issue that we saw in the valve. So those two are unrelated things. The moisture we saw in the valve is atmospheric moisture. So it is not intrusion moisture. Was there another piece to your question, Chris, that I missed?
Well, yeah, I was just wondering, is that going to require any kind of a redesign on your part, or do you feel okay with how it is?
So it's too early to say. We've got to go look at the valve itself and determine that root cause. Like I said, we're seeing that the NTO, we know there's some permeability with those seals. I mean, that's the physics of it. So we got to go look and see if there's something with the design that's causing the moisture penetration into the solenoid cavity. So at this point, I can't say whether it's a redesign or whether it's just some preventative measures that we need to take, but we'll work with our vendor, Aerojet Rocketdyne, to make sure that we resolve that.
And Chris, this is Joel Montalbano. As far as the cargo missions, as you pointed out, we only have 2 docking ports. And so once a date is selected with the Boeing Commercial Crew Program, ULA, we'll work with them to look at where's the best place, and adjusting a cargo mission may be the solution. It may be something we'll have to do, but we'll wait for a date is selected and then go from there.
And our next question is from Kristen Fisher, CNN.
Hi, everyone. Thank you so much for doing this. I know we're focused today on Boeing Starliner, but I have a question for Kathy or Joel about a slightly different topic. Russian state-owned media is alleging that a top Roscosmos official is accusing a NASA astronaut back in 2018 of suffering from some kind of medical or mental issue on board the International Space Station and then drilling a hole into the Soyuz in order to speed up her return to Earth. So what is NASA's response to this, and will NASA defend this astronaut? Thank you.
Absolutely. So let me tell you, our NASA crew members, they perform their missions with professionalism and integrity. And Serena is an extremely well-respected crew member who has served her country and made invaluable contributions to the agency. And I stand behind Serena. We stand behind Serena and her professional conduct, and I did not find this accusation credible.
Our next question is from Michael Sheets at CNBC.
Hi, all. I know we've really got into the too early to tell zone in terms of timing goes here, but in terms of understanding a little bit of the opportunities that are available over the next 8 to 12 months, how many launch opportunities and windows are actually available to Starliner for OFT2 to move forward in the future, and when are those?
Probably not a fair question for John. This is, I would say, we probably haven't looked that far ahead, right? I think we'll need to do a little bit of troubleshooting and understand what the potential root causes are and what we do to remediate it and then find the window. Joel and I just haven't necessarily had the time to go look at the windows later this year or into next year and when those are. So I apologize, I don't have an answer for that question today. I personally have been focused on working side by side with Boeing to try to resolve the problem for the last 2 weeks, so it's just too early for us to have that data.
Our next question is from Jeff Faust, Space News.
question for John Vollmer. You mentioned the valves were checked prior to rollout. Just how soon before rollout were the valves checked? And is there any differences in the valves used on the OFT-2 spacecraft versus OFT-1 in terms of any design or just sort of the general concept of operations for launch preparations? Thanks.
Okay. Yeah, so we fueled the vehicle up about 5 weeks before rollout. And so at the time of fueling up the vehicle, we had checked out all those valves, and all of them operated perfectly. Those valves are the same design as we used on both the OFT and the paddleboard test. So no changes either to the valves or the methodology with how we operate them.
Our next question is from Eric Berger at Ars Technica.
Yeah, hi. Thank you for doing this. And I guess my question is about the NTO permeation of the valve that John Vollmer referenced. It doesn't sound like that's nominal, and it to the layperson, a non-engineer, it sounds a little bit scary that you would get this oxidizer permeating a valve that's supposed to regulate flow through the propellant system. So maybe you could walk us through that issue and whether it was sort of like expected or not. Thanks.
Yeah, thanks, Eric. So, yeah, actually, it turns out that anytime you got moving parts and you're in a valve and you're trying to seal things, you've got to have seals in there. The seals that we use are Teflon seals. They're the only thing that really withstands the NTO because the NTO is a pretty corrosive oxidizer. So that's one of the things that stands up well to the NTO. We know just the physics of it is there is some permeation through that seal. The cavity that it permeated into was intended to be a vented cavity so that it did not, vented any moisture out of that cavity. And in fact, the design is such that when you get on orbit in a vacuum of space, that it actually pulls that down to a vacuum such that you would have no moisture in there. So we've got to go back and look and see, was there some ambient moisture that was retained in there when we were during assembly of these valves, or was there something that caused, a leak of moisture to get in there? So we understand the physics of how the NTO and the permeation of the Teflon seals. So that's a understood phenomena. I think the issue that we're dealing with here is how did we get moisture on the other side?
Our next question is from Kent Chang at New York Times.
Hi, thank you. Just to follow up again about the valves. There was fuel valves, oxidizer valves, and helium valves. Were the 13 all one type of valve or not? And is there a pattern among the 4 that remain sticking? And I was also wondering how much of a cost there is to Boeing because of this additional delay.
Again, this is John. Yeah, that's a fair question. Actually, there's 24 of the oxidizer valves, there's 24 fuel valves, and then there are 16 helium valves that compromise the system. They are all of the exact same design. The only valves that we saw issues with were with the oxidizer, and that's due to the phenomena that I described with the permeation of the NTO through that. So we had no issues with any of the fuel valves, the less toxic corrosive substance, and of course the helium is more inert, and we didn't have any issues with any of the helium valves. Once again, all of the same design. So it's a factor that goes with the oxidizer, and it's limited to just those oxidizer valves.
And the potential cost to Boeing?
I'm sorry, can you repeat the question, please?
How much cost will this be to Boeing because of the delay?
So I don't have a pat answer for you on that right now. that's something we'll have to work through and look at what the impact is. Part of it will be driven by what the solution is and the corrective actions that we have to take. So it's a little premature right now for me to say I have an answer on exactly how much that's going to cost.
And our next question is from Micah Maidenberg at the Wall Street Journal.
Hi. In 2018, some of the abort engine valves failed to fully close during tests. Are the new problems similar to what came up in 2018 with the valves? And were those earlier problems addressed? And if so, how?
So that was a different valve, but it's still part of the same propulsion system that's provided by Aerojet Rocketdyne.
And John, I was around at that time. Those are totally separate valves. This is Steve Stitch. That was in the service module hot fire testing. We did go figure out the root cause on those valves. Those were on the launch abort engine. Those have been corrected and fixed, and it's a totally different kind of valve. Those valves are actually actuated via pressure, right? It's a pressure-assisted valve. These are what we would call a solenoid valve, which are electrically actuated. So that was totally unrelated to what we saw on the August 3rd launch attempt.
And our next question is from Andrea Leinfelder at the Houston Chronicle.
Hi. Sorry to go back to the timeline again. I know we talked about Lucy and we talked about the cargo mission. Could you please tell me if there are any other launches you guys are watching that could interfere with this, or if there's any other traffic that should be on our radar? Thank you.
Yes, this is Steve Stitch, Commercial Crew Program. So we talked about the Lucy mission, an important NASA planetary mission in October. Also in October, we have the Crew 3 mission with SpaceX. That's a crew rotation flight. October 31st is the current launch date. That mission is designed to rotate up 4 crew members, and then we would return to Crew 2 in the November timeframe. That vehicle will be coming back with the crew that's up there right now from a NASA perspective. And then, Joel mentioned the cargo mission. I can't recall the launch date for that. There's one cargo mission that's going to launch on the August the 28th, CRS flight, and then another SpaceX flight at the end of the year in December.
And our next question is from Tim Fernholz at Quartz.
Hello there. Thank you for taking the time to talk to us. I just wanted to ask again about the financial impact to Boeing. I just want to make sure under the contract structure, whatever costs there will be covered by Boeing, I assume, just to confirm that. And then in terms of the details of what's going to happen next, how long will it take to transport the vehicle back to the factory? And when you do that, what will you do with it there? Will it need to be disassembled entirely? How long will it take just to break it down to the point where you can start investigating this? And can you share anything about what you intend to do to continue this investigation? Thank you.
Okay, yeah, I'll take that one. This is John Vollmer. So the process for what we call destacking the Atlas V vehicle is basically identical except reverse of the stacking process. They will pull the Starliner vehicle, the crew module and service module off. They will lower that onto the transport vehicle. It takes several hours for the transport vehicle to get from Launch Complex 41 back to our factory, the C3PF. When we receive that into the factory, it will be unloaded from the transport vehicle, and we'll put that into our fixtures. There'll be, and I don't want to sound like I'm avoiding the answer, or the question, but we will put that in the stand, and we will not take apart that configuration until we have gone through a complete engineering analysis of which pieces of the system we need to take apart. our intent will be is to disassemble as less as possible so that we can minimize any changes to the configuration. So like I said, we'll work root cause. We'll see what parts of the vehicle we must take apart. And so, we'll dig into it as much as we have to and take it apart as much as we have to. But at this point, I can't tell you how much that is. So I really don't have a good answer for you until we get in and really dig into it.
And can you confirm just that under the contract structure, Boeing will be covering whatever the costs are necessary to get this back to the pad?
I don't know that I have the complete answer to that. I'll work that with corporate, but don't speculate that we don't have an answer. An answer will be forthcoming. I just don't have that answer today.
Okay, thank you.
Our next question is from Stephen Clark, Spaceflight Now.
Thank you, Stephen Clark from Spaceflight Now. A couple of questions for John. Are you expecting to need to drain this oxidizer once you get back to the C3PF to continue this troubleshooting, or can you do some of the troubleshooting with the tanks loaded? And just so I understand the propulsion system architecture, are these valves associated with OMAC engines, RCS thrusters, the abort engines, or do these valves feed flow propellants to all of those thrusters? And then, if I could, for Steve Stitch or Kathy Leaders, any commonality between these thrusters, or these valves, and valves on other human spacecraft like Orion or Crew Dragon? Thanks.
Okay. Hey, Stephen, I'll take the first part of that one. This is John. Yes, there are reaction control system thrusters for both the propellant and the oxidizer. There is also OMAC thrusters, which are orbital maneuvering thrusters. And so there's both an ox and a fuel manifold for those. Now, these valves are the isolation valves from the main tanks, and so the main tanks run into manifolds, and then the manifolds run down to the thrusters. So yes, these valves control the flow of both oxidizer, fuel, and then the pressurant, which is helium, that pressurizes the movement of that commodity through the system.
And then I'll address, every spacecraft has this sort of system. It's in place to isolate, as John said, the propellant. If you needed to isolate a leak in a manifold, the space shuttle has these same kind of valves, and Orion has the same kind of valves, and not necessarily the same exact design, but they are oxidizer compatible valves in manifolds and just every spacecraft that I'm aware of.
So I think that's why it's important for us to understand what's going on with these valves, and obviously from a NASA perspective to understand what's different, and we do understand the differences between each of the valves, and so and obviously from a NASA perspective, understand the designs. Until the Boeing folks get the valves off, we don't understand exactly what's wrong with the valves, right? So this is where us collaboratively working together is really important. And as the Boeing guys find out what's wrong with these valves, we'll be able to go understand how the particular design or whatever issue that's there then pertains to the other valves that we have in our system, in our other systems. Obviously, we have these kinds of valves in all of our systems because this is a typical kind of design on all the spacecraft. But like Steve says, there's different kind of nuances to environmental protection or other things, and what we need to do is better understand what went wrong here and then go and do the work to understand how that applies to the rest of our other designs. Don't have that data yet, though.
Our next question is from David Curley, the Discovery Channel.
Thanks, Josh. John, I'm a little confused. I hope you could provide some clarity. You talked about atmospheric moisture, talked a lot about the rain, but then you suggested it could have come in at the factory. Can you give us some clarity? The reason you mentioned all this is that you don't know at this point. And then Steve or Kathy, I hear the frustration in your voices and I hear the commitment to continue working, but are you having any thoughts about this program overall? Thank you.
I don't think we have frustration. so let me make sure that I think I would tell you we're a little sad. We were getting ready to go fly. I'll talk to me personally, and Steve needs to jump in. We were getting to go fly, and we were really close to flying. And when that happens, and we're very excited about seeing the system go work. I know the whole team was very excited. You should have seen how excited everybody was to go get ready to go fly. And so that's why I think it shows the mental toughness of a team to not just keep pushing on flying, but to make sure that we're really then ready. We are really ready to fly when we find something new out. So you might be hearing us a little tired because teams have been working really hard, more John and Steve than me, but we're not frustrated. I would say I'm a little sad because I really wanted to go fly, but I'm also very proud of the team, and I'm hoping that they are making the right decisions along the way to make sure that we're ready when we go fly. These are the kinds of things you want to find on the ground. If we would have flown and had these valves, and John has all kinds of checks in places, but if for whatever reason this was something that looked okay, and then on orbit after we were on station, if things would have not opened, that would not have been good. So I'm very happy that these are things we're finding here and that we're working through it. And go ahead, Steve, jump in, sorry.
Yeah, I hopefully my voice, probably Kathy is right. I think, John, his team is tired. I'm tired. I think, disappointment is probably more in my voice because we were gearing up and being excited to go fly the flight. I would give you an analogy in sports. We're getting ready for the big game and excited about the game, and then the game goes away. And so that level of disappointment and excitement when you're getting ready for the big event and it doesn't happen, that disappointment is, I probably can't describe in words what that's like for somebody in this business. I think John talked about the valves and he can add to it, but whether the moisture was introduced in the assembly of the valve or in checkouts of the valve in the factory in the C3PF or at the pad through a release system, it's probably too early to tell. We do know that moisture on that dry side of the valve, where oxidizer can permeate across that Teflon seal that John talked about, forms this nitric acid and then could cause stiction on that side of the valve. So I think it's probably a little early to say where it happened. I think once we are able to get our hands on the valves and start looking at it, we can maybe make some progress as to what that cause of it was and how we mitigate that in the future.
Yeah, that's a good read, Steve. And so really nothing to add to that. But I do want to just echo that, while the team is disappointed, this is a team of seasoned human spaceflight professionals. And, they reacted to this situation with total professionalism. There was nobody moping about. These folks, they went straight to work. They pulled up and, looked at the innovative solutions. What do we need to go do? We adjusted shifts. We were around the clock with 3 shifts a day, so to cover 24/7 ops. It's just that's what we do in this business, and it's just that's how we go.
And for clarity, John, it could be the rain, or are you ruling out the rainstorm?
The rain, direct impact by the rain is not. We do not believe that's a factor, because these are under protective covers. The high degree of moisture in the atmosphere may have been a contributor. That's something that we're looking into. We know that our last flight was in December, so it was a totally different kind of atmospheric conditions. So, we're really trying to look at what was we haven't seen this problem in the past, and we're seeing it now. What's different between our previous and current? And so I can't rule out that it was an atmospheric environment condition. I will say I don't believe it's direct impingement of water on the valves themselves, but rather maybe heavy moisture content in the atmosphere. But we just don't know totally right now.
Our next question is from Marcia Smith at Space Policy Online.
Thanks so much. If you could just clarify what these thrusters are used for. So if you had not discovered this problem, would Starliner have made it into orbit? And if it made it into orbit, could it have maneuvered to the space station? If it could have done that, could it have re-entered safely? I'm still not quite clear which thrusters these were.
Okay, so I'll answer it. This is John. Yeah, so you are correct. We have the orbital maneuvering and attitude control thrusters, and we have the RCS, or the reaction control system thrusters. The orbital maneuvering and control we call OMAC. Those thrusters are the bigger thrusters. They are used for some of our orbital insertion burns and some of our deorbit burns. So those are the larger thrusters. The reaction control system thrusters are thrusters that we would use for fine-tuning, yaw pitch roll, and also as we did rendezvous and docking, we would utilize those precision thrusters. So we had oxidizer valves on both of those systems that had issues. We used the identical valves on both the OMACs and the RCSs, and so we experienced failures of valves on RCS and OMAC thrusters.
So you would not have made it into orbit, is that correct?
This is Steve Stitch. I would add one thing, and John, I think, talked about it earlier. The launch commit criteria is that all these valves are open right before we go launch. So we would have made it in. We would not have launched until all the valves were open, and we had total redundancy across our 20 orbital maneuvering and attitude control engines and our 28 reaction control engines. So the thing that stopped the countdown was that we had 13 of them that weren't open, and so we stopped the launch and held down because we knew we wouldn't have had propellant flow to those orbital maneuvering and attitude control engines and also the reaction control system engine. So that's why we stopped the countdown.
So yes. The ground checks ensured we were in a configuration to be able to get to the space station.
And with redundancy, and with full redundancy. Yeah.
Correct. Yeah, the system has two fault-tolerant redundancy, and yeah, that's exactly why we check these valves in our pre-launch checkout. So, yeah, and they have to all operate before we are go for flight, and that's why when they did not operate, that's why we called stop on the flight.
Thank you.
Our next question is from Mark Carreau at Aviation Week.
Yeah, I have two quick ones, I think. Where's the location of the factory that where the work will be carried out going forward? And does anyone know the end of the Lucy launch window at this point?
I can answer the Lucy question. The Lucy launch period opens on October 16th, and I believe it closes on November the 7th. And John can answer the question about where the factory is. We call it the factory, but he'll tell you where it is.
Sure. The factory is on Kennedy Space Center. It's we call it the C3PF. It is adjacent to the vertical assembly building. Matter of fact, we are in its shadow many times of the day. It is the old shuttle processing facility.
Thank you.
Our next question is from Amy Thompson at space.com.
Hi, thanks for taking my question. I was just curious about the cargo that was going to be on board the Starliner and is it critical cargo that the crew needed? And is it possible to send it on a different vehicle? And also, what about the science hardware that was coming back down? How does that affect the research plans for the space station? Thanks.
So this is Joel Montalbano. As far as the cargo, there was nothing on this vehicle that was critical such that contributed to the crew safety or vehicle safety. It was more logistics type things like that, both going up and down. And so what we'll do is, like we always do, we're always kind of looking a couple vehicles ahead. And at this time, we don't see any adjustment for SpaceX 23 going up. We may make a couple adjustments coming down. We're still looking at that. But again, nothing on this vehicle that's going to significantly impact the vehicle or the crew.
We have time for about 2 more questions. Our next comes from Ken Kramer at Space Up Close.
Oh, hi. Thank you. Thank you for doing this. I think my question is for John Vollmer. Can you make clear, because I'm not sure what you said, are you preemptively going to replace all of these valves that had the issue or not? And can you tell us a little bit about the history of the NTO permeation, and what would you do to mitigate it? And are you going to look at the other service modules to see whether there is an issue with them? Thanks.
Yeah, so we will look across the board once we get this down to a final root cause. Like I said, right now, and just emphasize, this is our most likely root cause that we're looking at. So we've got to make sure that we've examined all the legs of the tree and that we understand that if it's this and something else, that we understand everything that needs to be addressed. So as far as a fleet issue, I have not gotten it far enough to say this is a fleet issue yet. It's certainly an issue on this service module. We do have more of these valves in the factory, so we will go and examine those valves. We will work with our supplier, Aerojet Rocketdyne, and look and see if there's something with this lot of valves or something with this manufacturing of the valves that's different from the others. All those kind of routine things that we will do as part of our troubleshooting and root cause evaluation. So until I do that, I won't know whether I'm replacing all the valves on this vehicle or the other vehicles.
Thank you.
And this is Steve Stitch. I would say the permeation of the NTO oxidizer vapor is a common phenomenon with the Teflon seals, which are typically used in these valves. So it's a problem we had to deal with in the space shuttle program, and we had numerous problems with thrusters in the space shuttle program with various corrosive products that develop as a result of the oxidizer. And so it's pretty standard across the industry to deal with the oxidizer vapor on these valves.
Did you have to replace those valves on the shuttle?
We did not have to replace the valves, and it was a different kind of problem. The main problem on the orbiters had to do with the oxidizer vapor in the thruster itself and the thruster seats, and how we handled that in processing due to the floor to air with the humidity sometimes caused the nitric acid, which would cause the valve seats to leak a little bit, and we ended up having some thrusters fail. So this was on a different valve, but a similar kind of issue.
Mm-hmm. Okay,
and our final question is from Jackie Wattles, CNN.
Hey guys, thanks so much for doing this, and I'm sorry I've been juggling, so I really hope I'm not making anyone repeat anything. But John, I just wanted to ask you for some clarification on something you mentioned earlier in the presser about some erroneous measurements that might not be related to the valves. Could you say a little bit more about what that is? And just wanted to also clarify whether or not there are any software issues identified, or if that, what you mentioned, maybe I was misunderstanding, about erroneous measurements that you guys were saying.
Sure, Jackie, I can talk about that. So we had seen some valve position indicator anomalies in some of the measurements we were seeing. And those valve position indicators are the indicators that tell us whether the valves are open and closed. And we had seen that and it corresponded with all of the heavy rain events that were occurring. So we had already started looking into that, and that's when we started. When we had this other problem come up, we immediately thought there was some sort of a relationship between the two, and it wasn't until we had further investigation that we discovered that they were unrelated events, and that there was some water intrusion that had caused the erroneous valve position indicator readings, and that they had nothing to do with this issue that's with the permeation of the NTO and moisture causing the nitric acid.
Thank you, John. And we'll now go to closing comments from Kathy Leaders.
Thank you, Josh, and thank you all of you for all the questions. You know, as you've heard here today, we have a team that is extremely professional on both the NASA and Boeing and ULA side. We were hoping to be able to recover the valves and be able to go fly again, but we were not able to do that. You know, we weren't able to answer some of the questions today, but what you need to understand is we are just finalizing that troubleshooting, that initial troubleshooting in the recovery process. So I know the team is committed to carefully working through this problem, fixing it, and then moving forward to fly again. You know, the team needs some time now to really be able to figure out what's wrong. And we will learn from this. We'll learn from this not only for the Boeing CST program, but what's great is from a NASA perspective and our ability to be able to work with so many different providers is that we will also learn better to be able to understand how to make the hardware more robust and potentially looking at other or gaining future experience too. So John and Steve will now go off, begin that more detailed troubleshooting process, and then start building the schedule that you all wanted us, you know, to be able to have, to be able to go figure out then what it's going to take for us to fix this problem and turn around and fly again. We will be flying. So, and when we get the new schedule information, we will be sharing that information on when we will be flying again. So look forward to the future planning. I know this team will be getting ready to fly once again, and we'll be letting you all know when we're going to be doing that. So thanks again for all the questions, the participation, interest. I really want to finish up by saying thank you to the dedicated team that has been working this for many, many months, and in particular over the last few weeks. We tried really, really hard to get there, but I really appreciate the fact that when we couldn't, we carefully and made the decisions to make sure that we're going to fly when we're ready. Thank you.
And thanks again, everyone, for joining us today for our update on NASA's Boeing Orbital Flight Test 2. You can listen to a replay of this teleconference by dialing 800-873-2012. Thank you and have a good day. Bye.
That does conclude today's